So this is our second set of notes in Unit 3, transformations, reflection notes. Actually, maybe our third set of notes. That other set of notes the other day was a mini lesson, though. Like I told you, it felt like a one-off at first, the notes we did on Friday, the graphing and equation of the line. But you'll see today why you needed to know how to do that. And so it'll make sense for you. It'll connect back today. But this is our second transformation that we're doing, the reflection. Don't forget what we did with our first transformation, the translation. That was just a slide. So now we're looking at a reflection. And a reflection is a flip over a line. The line that you flip over is called the line of reflection. Information we need to know. Each point in this image are the same distance from the line of reflection. I got an example out here for you. I mean, it's not on the graph, but you can see a reflection should look like this, a flip. So the main thing you should understand about your points is your points are going to be flipped. With our translations, and I don't have those notes on me, but I can use somebody's paper real quick. I'm going to use Zach's paper. With our translations, when we translated an image, the points still stayed in the same corresponding positions. Like J was here, J prime was here on this image, A was here, A prime was here, I was here, I prime was here. You'll know that's a translation because of the way the points are set up. They're in corresponding positions still. With the reflection, your points are going to flip. So A is here on this side it's over here. B is up here, it kind of flips over up here. C is here and it's here on this side, C prime. The points flip. Possible lines of reflection. So, possible lines of reflection we may give you. First one is a x-axis reflection. We'll just ask you to flip your image over the x-axis or the y-axis. We'll ask you to flip your image over either one of those axes. Those are the easy ones. For those, you don't have to draw a line of reflection in because you could just use the x or y axis. The ones that are maybe a little harder for us, but we can figure it out, is vertical or horizontal lines in the form of x equals a number or y equals a number. And we did these on Friday. And remember, x equals a number is a vertical line. Y equals a number is a horizontal line. Last one, diagonal lines in the form of y equals x and then y equals negative x. These are the main ones they'll ask you to do. There are some other ones that they'll ask you to do, maybe based off of, slope intercept form equation, but that's rare that we do that. And if we do, it won't be hard. But these are the main ones, these reflections, these 6. Symbolic form, how you'll see them ask you to do a reflection. So when they're asking you to do a reflection, there really is no mapping rule like there was with translation. The mapping rule only comes after you do it. I'll show you later. But symbolic form for reflection, how you may see it, how they may ask you to do it. They may use a capital R, and then after that they'll tell you either an equation that they want you to reflect over, a line, or they may say something like this, R the x-axis. if I see that on paper, that's telling me to reflect over the x-axis. Or they could use a lowercase r as well. You never know. And then they might say reflect over y equals 3. So they tell me put a line at y equals 3 and flip my image over that. They can use a capital R or lowercase r. They use the same thing for rotations too, capital and lowercase r. But you'll know you'll know the difference between a rotation and reflection, because a rotation, instead of telling you to rotate over the x-axis, will never ask you to do that. They'll give you degrees of rotation. They'll say rotate 90 degrees, rotate 180 degrees, rotate 270, rotate 360. Well, never ask you for 360. But they'll give you degrees of the rotation. You'll know the difference between the two. Alright, so that's all the jargon, if we want to call it. Now here, let's actually do some reflections. Graph and label each figure and its image under the given reflection. Give the new coordinates. So we're going to reflect our image, give our coordinates. This first reflection. It says triangle ABC with vertices A, -4, 2, B, 4, 7, C, 5, 1 on the x-axis. They're telling us reflect over the x-axis. One thing y'all can do for yourself, I know my kids last year like to do it, use a highlighter instead of maybe using their pen, and just highlight their line of reflection. Here it's going to be the x-axis for me, so I'm flipping over that. If you don't have a highlighter, just use a pen, bold it with your pen. Just understand what you're flipping over. So I'm graphing my first image first. -4, 1, 2, 3, 4, up to B is at 4, 7. C is at 5, 1. So it's A, B, C. This is my pre-image right here, and then obviously when we flip it over the x-axis, since I'm flipping this image over the x-axis, the majority of all this image is going to flip which way? What you say, Taylor? What? I said since I'm flipping over the x-axis, the majority of or all of this image is going to flip which way? This ain't a trick question. Yeah. Jesus. It's going to flip down. To do a reflection, it's pretty easy. Go to your line of reflection and line up under whichever points you want to reflect and count. So line of reflection, I go up to A, it's 1, 2. That's saying A is 2 spaces away from my line of reflection. I go back down to my line of reflection, I go the opposite direction too. 1, 2. This is now my A prime. Line up under B on the line of reflection, count 1, 2, 3, 4, 5, 6, 7. 7 up. So go back to line of reflection, going 7 down. 1, 2, 3, 4, 5, 6, 7. B prime. C. 1 up. When I line up under it, 1 up. Go 1 down from the line of reflection. C prime. it off. And it's got the reflection over the x-axis, and then we can split my coordinates out. Jalen, A prime as well. -4, -2. B prime. -4, hold on, say it again. Messing me up. Wrong. What? Yeah, you made me write that in pen too. Thanks a lot. That's not a -4. That's wrong. That's just +4. Where's C at? C prime. I'm sorry. So, I still to this day I do my reflections like this. I just count real quick. It's pretty easy for me to do. It's pretty easy for y'all to do. Now, there are reflection rules. There are reflection rules for only certain reflections, though. I can give you a reflection rule for an x-axis, a y-axis, and then I'll show you the other two. But you can figure out this reflection rule for yourself. There's a mapping rule they give you for this reflection, but you have to understand what happens to the coordinates. For example, at the top, your original A was -4, 2. Your A prime ended up being -4, -2. Your original B was 4, 7. Your B prime ended up being 4, -7. What happened? Even C. C was 5, 1. C prime ended up being 5, -1. What happened to your coordinates? Say it again. Yeah, the y changed to a negative, right? But I don't want you to think the y just changed it to a negative every time. What happens if your y is already negative and you're reflecting? It's going to turn positive, right? So really what happens is when you're reflecting over the x-axis, the only thing that changes is the sign on your y, yes? There's a mapping rule you can write for that. So out to the side, I'm going to write it for you. Reflection writing ugly right now. Over the x-axis. Whenever you do that, the mapping rule says your xy, parentheses x comma y, maps to the arrow that we use, x, change in y. Let me zoom in on that. The rule for reflection over x-axis is your xy maps to x, change in y. All that's telling me to do, if I look at this, is saying keep my x values the same, change my y values. It's not saying turn y negative, because y is already negative, like I said. You should know that turns positive. Anytime we put minus signs in these rules before x or y, we're just telling you to change the sign. We're not telling you to turn stuff negative, because if something's already negative and you just keep it negative, you didn't do anything to it. Alright. Slide on. Next one. Rectangle, PQRS. They want us to flip that over the y-axis. One, two, 2, 5. 8, 3, and 7, 0. This is P, Q, R, S. So let's not waste time. Let's flip. I go in the order in which they name it, but you go whatever order you want to move your stuff. It don't really matter. I don't care how you. Actually, yeah, you can. It's just when you draw your lines, make sure you draw your lines based on the way they name it. I should have said that when we started the other day too. Some kids, when they end up drawing their figure, they have crisscross lines and stuff because they don't. When you're drawing your lines on your figure, make sure you connect it based on the way it's named. And y'all see that when we get into some of these other figures that are a little more wackily shaped. Kids don't be knowing how to connect their lines. So P is here, one away from the y-axis to the right. I'm going to the left one. I'm sure most of y'all have picked this up. It's not a hard concept. Line up on Q up here. It's 2 away from the x-axis. I'm going to the opposite direction. Q prime. R is 8 away, all the way on the end. I'm going to line up and go to the other end the other way. R prime. S is 7 away down here. Go down here, go 7 away over here. S prime. Y'all see me labeling my stuff. Your stuff better be labeled as well. You're doing both images, so I should be able to tell which one is pre-image and image just by looking at your paper. If I look at your paper and I can't tell which one is pre-image and which one is image, then I'm gonna be very upset. Just save me, I'll give my coordinates. P prime. I said P prime, but okay. The first one is P prime. I mean, it's down at the bottom. It's the first one. -1, 2, Q prime. You're whispering, but okay. Uh-huh. So she just read those to me. Tell me, we flipped over the y-axis. What happened to our coordinates versus our original coordinates? What you mean by flip? Hey, if you notice the sign on our x's changed. Don't think they. I don't want y'all to keep saying this positive, negative thing. Y'all gonna get caught up if they start out negative and y'all ain't gonna know what to do. The signs are changing on your x value. Like I said, if we started over here, negative, and we had to flip over x-axis, they would turn positive. If all y'all see what I'm saying. So don't think that everything is turning negative. That's not the case. It's just your sign is changing on your x values. So obviously out to the side, I'm gonna write another reflection rule for you. Reflection over the y-axis, xy maps to change in x, comma, y. So honestly, if you're in a situation, and we may do this on a test for you, but you could always graph if you want. If you know the reflection rule for x and y reflection, sometimes we only ask you about 1 point. Like if you reflect this point over the x-axis, what happened to it? If you could do that in your head, then you don't have to graph it. You know the rule, but it's hard. For me, it's easier to just graph real quick and then do the stuff, because there's going to be so many rules that you're going to be getting by the end of this. It'll just be easier to do everything on a graph. I'm going to give y'all all the rules, because some kids like trying to memorize the rules. But the way I teach you transformations, you'll never have to memorize the rules. You can always use graph paper and get your stuff right. It's going to take you a little bit more time, because by the end you're going to see there's like almost 8 or 9 rules that are almost similar, but they're for different things. Like when we do rotations, the rotation rules look similar to this. They're just a little bit different. And so trying to remember which thing is negative, which thing isn't, which is flip, which one isn't, it's a lot sometimes. I'm going to teach you how to do everything by hand. And you can always do stuff on a graph. I will always provide you with a graph when you're doing transformation stuff. Even on EOC, they give you a big old graph on the back of your worksheet. If you need more work paper too, we'll provide that for you as well. You can always ask for graph paper or do anything on the graph. On the back, number 3, it says triangle JKL has vertices of on x equals 4. So this is where they want us to reflect over the line x equals 4. So we got to put a line in at x equals 4. Well, luckily for you, Mr. Bunsen taught you how to do lines like that, x equals 4, so you should know where to put that in at. Go to 4 on your x-axis, put a point there. And then we draw a line of reflection. Jeremiah, is our line of reflection going to be horizontal or vertical? I'm asking Jeremiah. Huh? That's fine. You're going to say the wrong thing anyway. She said horizontal too? Okay. Well, obviously it's vertical. All you got to do is look on the front. You still got notes. What did I say about x equals? A vertical line. Even if you can't remember. You use your notes until you're behind remember. I'm going to draw this one in with my pen first, and then I'll come back over with a highlighter. My line of reflection here. So I put my line of reflection on. That's the first thing I want to do. Then after that, I want to graph my image. My pre-image, excuse me. 1, -1. J. 2, 3. 2 up. 1, 2, 3. K. 3, -2. L. So this is J, K, L. My triangle, it's a smaller triangle. Looks good. It makes it life easier for us. Now Now that I have my line of reflection, that's the line I'm rotating over. I mean, flipping over, not rotating. That's the line I'm flipping my image over. I'm not worried about any of these other lines. I'm not worried about the x-axis or the y-axis. I'm not even looking at those. I'm flipping over this line of reflection right here. So then you flip your image. From that line, who can I ask? Billy. I'm going to start with point J. That's my first point. How far is point J away from the line? Maybe you didn't hear me. Billy. How far is point J away from the line of reflection? 3. 3 to the left, right? So I'm going to come back to the line of reflection and go 3 to the right. 1, 2, 3. Here. This is my new J. This is J prime for me. Billy, the K was the next letter, so go up to K. How far is K away? 2. 2 to the left, yes. So I'm going to come and go 2 to the right. K prime. Last one, L. 1. It's 1 to the left. I'm going to come back to the line, go 1 to the right. This is L prime. Connecting dots. If you do it correctly, your image should look like a reflection. Last thing you need to do after that, the most important part too, is getting your coordinates. Now listen to me. We're pulling our coordinates from 0, 0. So we're pulling our coordinates from here. Billy, you can help me. Where's J prime at now? Is that where? At who? Come back to you, Billy. Tim. 7, -1. Yeah, go ahead, do them all. 6, 3. And then L prime is at 5, what? Negative who? 5, -2. Alright. My bad, I didn't know I wasn't showing y'all these. Sorry. So last and most important part is pulling your correct points. Now on these, this is what I'm talking about. Anytime you have x equals a number or y equals a number, there's no rule I can give you for these. So there's no rule I'm about to write for you on these. There isn't one. Now some kids, I forgot, it was like 3 years ago, swear they figured out a rule for it. It didn't make sense to me, and I ain't never heard of it. But I guess it worked for that person. I don't know. Ain't no rule for these, though. You just gotta do them. What's next? Oh, next one. Parallelogram CDEF. You want to reflect that over the line y equals 2. Y equals 2. Jeremiah. Horizontal or vertical line? Huh? Horizontal. Thought you said vertical. You scared me. At y equals 2. On the y-axis, I went to 2. Positive 2. I'm going to do a horizontal line there. Bleeding a little bit. There we go. Graph your image. Okay, I'm wait on me. You can go ahead. should make y'all do this one on your own. -4. Okay, where we at? C -4. -4. -4. -2, -2, 0. D. 6, 1. E is at 6, 1. F is at 4. Also 3, 4. C. I don't know, this is C. Tripping. I'm about to say that don't make sense. C, D, E, F. There it is. After that, flip our image. Tyler, hit us with them, man. New coordinates. C prime. You not ready yet? I can't hear him. What do you say? Yes, no, maybe? Maybe not. Say it again. Okay, -4, 8. B prime. Yeah, man, let's roll. -2, 4. All right. think it said 6.3. Last one. Say that again. Nah, that's the only one I don't agree with. Torres, what you got? La Lotta? Yeah, 4-7. Alright, let's get into it, man. Oh. We got two more. These. I don't know how I feel about these. Kids find it okay. Y'all just gotta pay attention to what I say. It's not hard. These are pretty easy. Y'all just gotta know where to put the line of reflection in it. This is where kids mess up the most on these two. Because even after all that we did on Friday, y'all even did it again on Monday, those who came to school and actually did something, kids still be messing up on the x equals and the y equals lines of reflections. And they're not that hard to do. They put the lines in wrong, to be honest with you. And that's when they reflect wrong. If you can put the line in right, you should be good. Number 5. It's triangle, excuse me. Triangle x, y, z. They want us to reflect over the line y equals x. So y equals x is an equation. It's a slope intercept form equation. That being said, to figure out what our line is going to look like, let's figure out what our slope is and what our intercept is. So I'm looking for my M and my B. Any volunteers? Same two people, yeah? Rama, what's the slope of this line? I can't hear you, talk louder. You know how I need it though. I need it as a fraction. What? Okay, well tell me that then. 1/1. What's the y-intercept? 0, right? Because there's nothing after x. Well, there we go, right there. I can draw a line from that. Put my intercept on first, which is at 0, and then my slope is up 1/1. Do it again, up 1/1. Do it again, up 1/1. Up 1/1. I'm just putting some points on here to show you that it's just gonna keep going. Draw my line in. Let me line up. You draw correctly, your line should be one of those perfect diagonals that goes through 0, 0 on the graph and cuts through. It's going to be a positive diagonal line that goes through 0, 0. The slope of 1/1. That's the case. This is the line that they want me to reflect my image over. Not hard for us to do, just different. Say it again. Similar. Your counts are going to be a little bit different. Because before we just either count to the left or the right, and then up or down. Kind of got to mix it now. Hold on. Alright, so graph this first image, the triangle. -5, -2. So over -1, 2, 3, 4, 5. Down -2. -3, up 4, and then -1, up 1. So this is x, Y, Z. So the concept, yeah, is similar. We're trying to flip over this line, but this line is diagonal. So you got to understand your action when you flip over the line. If you're going to count, and you can't count, you just got to understand what you're going to do when you're counting. So me, first I would look at this X right here. I'll say, how far is this away from my line of reflection? For me, it's 1, 2, 3 spaces away from my line of reflection. Y'all agree on that, yes? When I go back down to this line, though, what I don't want to do, I don't want to go down 3. Even though it's up 3. Since this line is diagonal, kind of do like the opposite. Since this is up 3, when I come back down to the line, I'm going to go to the right 3. Instead of going down 3, I'm going to go to the right 3. I'm going to go 1, 2, 3 over here. In that direction. That's all what I did. I need me to do it again. For my Y, I'm gonna line up over that. It's up 1, 2, 3, 4, 5, 6, 7. So it's 7 spaces up from this line of reflection. If you look, I can't even go down 7 if I wanted to. On this one, it's a diagonal reflection. It shouldn't let me go down 7. It'd be off the graph. When I come back to this line, since I went up 7 right here, I want to go to the right 7 over in this area. Diagonally flip it. So over 1, 2, 3, 4, 5, 6, 7. This is gonna be my Y prime. The last one is Z. Z is 1, 2 up from the line. Go back down to the line. Don't want to go down 2. I want to go to the right 2. Over 1, 2. Make this my Z prime. Then I'm connecting. Overdrew my line a little bit. If you draw it correctly, it should look like a reflection over the diagonal line. It's a reflection over the diagonal line, Y equals X. I know some of y'all might not have thought that off that, so we got another one we're going to do anyway. Let's get our coordinates first. Y'all be taking too long. Who can give me coordinates fast? Go ahead, Tim.
For X prime, it's -2, -5.
-2, -5,
Y prime is 4, -3.
4, -3.
For Z prime, it's -1, -1.
It's what?
-1.
Try it again.
Sorry, 1 negative.
There it is. So, good news for y'all on this one too. There is a reflection rule here. Somebody discovered it for us. Trying to figure out where to write it at. We got my film on it. Nobody? No. Reflection over Y equals X. We got a mapping rule here. Look at your original coordinates and look at the ones you wrote down here with 10. What happened? I want everybody to see it. My original x was -5 and -2. My x prime is -2, -5. My original y was -3 and 4. My y prime is 4, -3. My original z was -1, 1. My z prime is 1, -1. Can't you see that the x and y just flipped, right? For those who are actually paying attention, yes? The mapping rule is xy maps to yx. That rule is telling you to flip your coordinates. Whatever your y was, that moves to the front. Whatever your x was, that moves to the back. If you use that rule, you can flip an image. So you can do that ahead of time if you wanted. So, like, instead of counting like I did, if you want to use this rule, but you have to remember this rule though. If you can remember this rule, you can use this rule and apply it on here. You can just find out what your x coordinate is. Like, I wouldn't even have to look at the graph. I would just go up here. If I knew that rule, I would say, okay, -5, -2, flip my coordinates, -2, -5. That's gonna be my x prime. My z is gonna be, like I said, 1, -1. If I knew the rule. The rule is available to y'all, but it's something you gotta commit to memory, along with the other rules. But you can always count. I like to show y'all how to count too. I still count. So I forget the rules sometimes. This one not so much. I don't forget this one, but I still just count anyway. That's just me. What? I'm telling you, by the time I give you all these rules, you're gonna be like, you know what? I might as well just use the graph. Next one, y equals -x. Moving quick because I want to finish this video. Same situation. Got m and b. What's my slope for this one? Go ahead, Tim. -1/1. Intercept 0. Graphing this one. 0. Slope is -1/1. -1/1. -1/1. -1/1. -1/1. Just putting points on my graph. This time my diagonal line is going down. It's a negative diagonal line. Graphing my image. A -1 up 3. 1, 2, 3. B is at 0.6. C is at 3.5. Then 2 up 2. So it's supposed to be a square. If you graph it right, it'll look like a square. A, B, C, D. Flipping that over the y equals -x line. Same thing as before. I can count if I wanted to. So it's time. With this line, I'm up. For my A, I'm up 1, 2. I go back down to the line. Which direction do you think I'm about to go? Say it again. To the left. Going to the left. 1, 2. A prime. Go back up to my line. B is up from the line. 1, 2, 3, 4, 5, 6. Go back down to the line. I'm going to the left 6. B prime. C, line up over that, is up 1, 2, 3, 4, 5, 6, 7, 8. Go back down to my line. I'm going to the left 8. 1, 2, 3, 4, 5, 6, 7, 8. D is 1, 2, 3, 4 from the line. Go back down to the line. 1, 2, 3, 4. Alright, so we need our new coordinates. Go ahead, Tim. Might as well.
-3, 1 for A prime.
-3, comma 1,
For B prime, -6, 0.
-6, 0.
For C prime, -3, -5.
-3, -5,
B prime, -2, -2.
Hold on. I think he gave me C wrong. Dang. I wrote that in pen. Give me C prime again.
-3,
No. No, you be quiet.
-5, -3.
-5, -3. There it is. So C prime is -5, -3, y'all. -2, -2. I'm going nowhere. We need to see what happened here. There's a rule for this one too, just like there's a rule for the last one. Reflection over y equals -x. What happened to our coordinates? The best example is to look at A and C. So A prime was -1, 3. The new coordinate changed to -3, 1. B prime was, B was 0, 6. B prime was -6, 0. C prime was 3, 5. It changed to -5, -3. What happened to your coordinates? Now you gotta give me something better than that. What happened to the coordinates? I can't hear you from way over there. Wrong. I don't want you to say turn negative. That's going to throw people off. They flipped and the sign changed. You saying they flipped and turned negative. -1 for A was already negative. That didn't turn negative, or that didn't stay negative. The signs change. I don't want y'all to say things turn negative. They don't. The signs are changing. The rule for this one was XY maps to a change in Y in front and then a change in X in the back. You flip and change the signs. The negatives don't mean turn stuff negative. They mean change the sign. Something's already negative, that's going to turn positive. More so than any other day, you are going to need your notes when you do your practice and stuff today. I don't see how you're going to do it without it. Unless you think you're that good already, and I doubt it.